Hi, today I'm reading fastai, a layered API for deep learning. This one is from Jeremy Howard and Sylvian Gagger. I'm reading this paper because I like Jeremy Howard. He has his fastai has very interesting videos about AI, which are very sort of practical, very useful. He's also interested in Swift for TensorFlow, which I think it's a good direction as far as I know. Because I think Python is too slow for sort of general purpose things you may want to do, and in general, I think Jeremy Howard in area of AI has very good points, about practicability, speed, and flexibility. In programming, created NBDEF and so on. So that's why I'm reading this paper. I'm interested in this library. I would like to maybe use it. So abstract is following. FastAI is deep learning library which provides practitioners with high-level components that can quickly and easily provide state-of-the-art results in standard deep learning domains, and provide researchers with low-level components that can be mixed and matched to build new approaches. It aims to do both things without substantial compromises in ease of use, flexibility, or performance. This is possible thanks to carefully layered architecture, which expresses common underlying patterns of many deep learning and data processing techniques in terms of decoupled abstractions. These abstractions can be expressed concisely, clearly, and leveraging the dynamism of underlying Python language and flexibility of PyTorch library. FastAI includes a new type of dispatch system for Python along with semantic type hierarchy for tensors, GPU-optimized computer vision library, which can be extended in pure Python, and Optimizer, which refactors out the common functionality of modern optimizers into two basic principles, allowing optimization algorithms to be implemented in 4 to 5 lines of code. A novel two-way callback system that can access any part of the data, model, or optimizer and change it at any point during training. New data block API, and much more. We have used this library to successfully create complete deep learning course, which we were able to write more quickly than using previous approaches, and the code was more clear. The library is already in wide use in research, industry, and teaching. I will try to find some core contributions if there is one. Okay, Highlevel API. I think they don't have that. Okay, let me see conclusion. Results and conclusion. Early results from using fastai are very positive. We have used fastai library to rewrite entire fastai course Practical Deep Learning for Coders, which contains 14 hours of materials across 7 modules and covers all applications described in this paper and some more. We found that we were able to replicate or improve all the results in previous versions of material and were able to create new data pipelines and models needed much more quickly and easily than we could before. We have also heard from early developers of pre-release versions of the library that they have been able to more quickly and easily write deep learning code and build models that with previous versions. FastAI has already been selected as a part of the official PyTorch ecosystem. According to the 2019 Kaggle ML and DS survey, 10% of the data scientists in Kaggle community are already using FastAI. Many researchers are using FastAI to support their work. Based on our experience with FastAI, we believe that using a layered API in deep learning has very significant benefits for researchers, practitioners, and students. Researchers can see links across different areas more easily, rapidly combine and restructure ideas, and run experiments on top of strong baselines. Practitioners can quickly build prototypes and then build and optimize those prototypes by leveraging FastAI PyTorch foundations without rewriting the code. Students can experiment with models, try out variations without being overwhelmed with boilerplate code when first learning ideas. Basic ideas expressed in FastAI are not limited to use of PyTorch or even Python. They are already part of the port of FastAI to Swift called SwiftAI. We hope to see similar projects for more languages and libraries in the future. Right, that was conclusion. Let me go back to the introduction. Okay, actually, let me go quickly through the paper. So we have interaction, then there is this figure, applications, high-level API, mid-level API, low-level API. So I guess those are the layers, right? These applications, high-level, mid-level, and low-level API. So applications have section for vision, some fiction for example, segmentation task, tabular, then some kind of text processing, natural language processing, high-level API design considerations. So here they have high-level API part, mid-level API. Many libraries, including fastai, earlier provide high-level API tools and lower API internal for the functionality, but nothing in between. So that's what the mid-level API does, I guess. Geometrized API func givers data loader, fast API core, layers and architectures, low-level API. Lower levels of its stacks rather than treating Python itself as a base layer for computation, which middle layer also, and those layers rely on set of basic abstractions provided by the lower layers. Okay. And BDEF, yeah, there is a section for MBDEF. I'm definitely gonna read this one. I think that's sort of an interesting idea. I've been trying to do something like that since I heard about it, so I'm definitely gonna go to that section. Okay, let's read the introduction. fastai is a modern deep learning library available from GitHub as open source. Apache 2 can be installed using the Conda pip and subject to book deep learning for coders with fastai. So there will be book AI applications without PhD. So it has two main goals: to be approachable, rapidly productive, while also being deeply hackable and configurable. Other libraries tend to force choice between the cohesiveness and speed of development, or flexibility, expressivity, but not both. You want to get clarity of development, the speed of Keras, and the customizability of PyTorch. This goal of getting the best of both worlds has motivated design of layer architecture. High-level API powers the ready-to-use functions to train models in various applications, offering customized model extensible defaults. It is built on top of hierarchy of low-level APIs, which provide composable building blocks. This way, user wanting to rewrite part of the high-level API or add particular behavior to suit their needs, they doesn't have to learn how to use the lowest layer. Yeah, they can use the mid layer. High level API is for beginners, practitioners, applying pre-existing deep learning models. The first concise API in four main application: text, vision, text, tabular, time series, collaborative filtering. There's some default values. For example, they provide single runner class which brings together architecture optimizer and data and automatically chooses an appropriate loss functions where possible. Integrating these concerns into a single class enables fastai to create a probability default choices. To give another example, generally training things should be shuffled and validation sets should not be. So fastai provides single data loaders class which automatically constructs validation training data loaders and data handled. This helps practitioners to ensure that they don't make mistakes such as failing to include validation set. This use of intelligent results based on our experience or best practice extends incorporating state-of-the-art research whenever possible. For instance, transferring learning is critically important for training models quickly, accurately, and cheaply, but details matter a great deal. fastai automatically provides transfer learning optimized by normalization training, layer fusing, discriminative learning rates. In general, the library use of integrated default means that it requires fewer lines of code from the user pre-specified information and merely connects the components. As a result, every line of code tends to be more likely to be meaningful and easier to read. Mid-level API provides core deep learning and data processing methods for each of these applications. Low-level API provide a library optimized, primitive, and functional object-oriented functions, which allows mid-level API to be developed and customized. The library itself is built on top of PyTorch, NumPy, PIL, Pandas, and various other libraries. In order to achieve the goal of hackability, the library does not aim to supplant or hide these lower libraries or the foundations. Within the fastai model, one can directly with underlying PyTorch primitives, and within the PyTorch model, one can incrementally add up components from fastai library as conveniences rather than as integrated package. We believe that FastAI meets its design goals, and user can create and train state-of-the-art vision model using transfer learning with 4 understandable lines of code. Perhaps more tellingly, we have been able to implement recent deep learning papers with just a couple of work hours, whilst matching the performance shown in the papers. We have also used the library for our winning entry on downbench competition, training a ResNet 50 on ImageNet to accuracy in 18 minutes. The following section describes the main functionality of the various API levels in more detail and review prior related work. We choose to include a lot of code to illustrate the concept we are presenting. While that code may change slightly as the library to its dependencies evolve, the ideas behind stay the same. The next section reviews high-level API out-of-the-box applications for some of the most used deep learning domains. The application provided as a vision, text, and tabular code with filtering. Okay, let's go. Applications. Vision. Fine-tune on ImageNet. Oxford Pets achieve close to the state of the art. Okay, so what they do here in the code is they import everything from the vision module. They untar the data, they extract the data. Then they use image loaders from name re. Okay, they somehow. Okay, image item random resize crop. They do some crop. They do augmentations. Normalize. They do some sort of normalization from ImageNet stats. Then they apply CNN learner with ResNet and error rate and fit one cycle for I'm not sure what this fit one cycle. So this is not an excerpt. These are all the lines of code necessary for this task. Each line of the code does one important task, allowing the user to focus on what they need to do rather than a minor detail. Let's look at each line in turn. So first line imports all necessary pieces of the library. The entries were written as a REPL environment as well in complex software system. Even using the import star, it's not recommended. REPL programmers generally prefer the symbols they need to be directly available to them, which is why fastai supports import star. The second download dataset, extracts it. This line setups data loader object. This is the abstraction representing combination of training and validation data described in later section. Okay, one interesting feature of this API, which is also shared by lower layers and API separation of the item level and batch level transform. Item level transforms are applied in this case to individual image on the CPU. Batch transforms, on the other hand, are applied to a mini batch on the GPU if available. While fastai supports data augmentations on the GPU, images need to be of the same size before being batched. Aug transforms selects sets of data augmentation that work well across the variety of vision dataset problems and can be fully customized by providing parameter function. This is a good example of a simple helper function. It is not strictly necessary because the user can list all the augmentations that they were, however, by providing single function which curates the best practices and most common types customizable by single functions, users have fewer pieces to get good results. Then you can do show batch and look at data. CNN learner creates a learner. That's an abstraction combining optimizer, model, and the data to train it. It will be described in section 4.1. For example, ImageNet pre-trained model is already available. Remove the classification head of the model, replace it with the head of appropriate for the particular dataset. Set of appropriate defaults for the optimizer, weight, decay, learning delay, and so forth are set. Fit one cycle. So the fifth line fits the model. In this case, it uses one cycle policy, which is the recent best practice for training, and it's not widely available in most deep learning libraries by default. It is annealing both learning rates and the momentums, printing metrics on the validation set, displaying results in HTML table. So you can use it in Jupyter Notebook. So it records losses and metrics after every branch and allowing plotted layering so forth. GPU can be used if one is available. After training the model, user can view the various link errors show results. The line. Okay, here's another example of visual application. This is time series segmentation with Gambit dataset. Okay, this looks very similar. Except they have this segmentation data loaders from label functions. So they have this f names, label func, this I guess provides labels, codes, txt, batch t, fms, again normalize, yeah, this does the augmentations. I guess these are the batch augmentations. Then some sort of normalization, then unit learner, fit one cycle, PCT start 0.9. The exact same line of code is used for the image classification. Example I'm going to use to display the segmentation data. So if you look at the image, you can see segmentation. Figure 5 for segmentation type, ground truth mask is laid on the right of predicted set. Okay. Then there another example for text. So here there's this Tokenizer as well, text data loaders from DF, we pass vocabulary, path, text column, language modeling through, language model learners, DLLM, LSTM, perplexity metrics are set to perplexity, and then fit one cycle. Biggest challenge with creating text applications is often the processing of the input data. fastai provides flexible processing pipeline with predefined rules for best practices such as handling capitalization with adding tokens. For instance, there is a compromise between lower casing all text and losing information versus keeping the original capitalization and end up with too many tokens in your vocabulary. fastai handles this by adding special single token representing that next symbol should be treated as uppercase or sentence case, and then converts the text itself to lowercase. fastai uses number of these special tokens. Another example is that a sequence of more than 3 repeated characters is placed. More than 3 repeated characters is placed with a special token along which number of repetitions and then the repeated character. These rules largely replicate the approaches discussed in 4 and are not normally available in the defaults in most NLP modeling libraries. The tokenization is flexible and can support different organizers. Default is used spacey. A sentence piece tokenizer is also provided by the library. Subroutine tokenization such that the sentence piece can be used in many recent NLP breakthroughs. Numericalization and vocabulary creation often requires many lines of code and careful management, where face caching handles transparently. Automatically input data can be provided in many different forms, including separate file names on each document, delimited files in various formats, and so forth. The API allows for complete customizations, and then pieces particularly useful for handling multiple languages, such as multi-fit along fastai for this purpose. This provided model state-of-the-art results across many different languages using the single code base. fastai text models are based on AWD LSTM. The user community have provided external connectors to popular Hugging Face transformers. The training of the models proceeds in the same way for the vision examples with the flows appropriate for these models automatically selected. We are not aware of other libraries that provide direct support for transfer learning best practices NLP, such as shown in 4. Okay, you can replace the tokenizer. Results can be visualized. Okay, tabular models not been very widely used in deep learning. Gradient boosting machines and similar methods are more commonly used in industry and research settings. However, there have been examples of competition-winning approaches and academic state-of-the-art results using deep learning. Deep learning models are particularly useful for datasets with high cardinality categorical variables because they provide embeddings that can be used even for non-deep learning models. One of the challenges is there has not been examples of libraries which directly support best practices for tabular modeling using deep learning. The Pandas library already provides excellent support for processing tabular datasets, and fastai does not attempt to replace it. Instead, it adds functionality to Pandas data frames through the various processing functions, such as automatically adding feature time useful for modeling with the data. fastai also provides features for automatically creating appropriate data loaders with separate validation and training sets, using a variety of mechanisms such as randomly splitting rows or selecting row based on some column. The code, sorry, what was that? Preprocessing functions such as automatically adding features that are useful for modeling with the data. fastai also provides features for automatically creating appropriate data loaders per train set. Randomly splitting rows, whatever. Collaborative filtering. So collaborative filtering is normally modeled using probabilistic matrix factorization. In practice, however, the datasets generally have much more than just, for example, user ID and product ID, but instead has many characteristics for the user, product, time period, and so forth. Quite standard to use those models, and therefore fastai attempts to close gap between collaborative and tabular modeling. Deployment, high-level API design considerations. So high level, okay, I'm gonna speed up. So high level API, which is used by most people, also share basic components. One such component is the visualization API, small number of methods, learner one cycle policy, hyperparameter schedule in the one cycle policy, learning rate finder that does a mock training with an exponentially growing learning rate over 100 iterations. Okay. Mid-level API. Many libraries include fastai version or earlier provide high level and low level, but nothing in between. This has two problems. First, that it becomes harder and harder to create additional high level functionality as the system becomes more sophisticated, because low-level API becomes increasingly complicated and cluttered. The second problem is that for users of the systems who want to customize and adapt it, they often have to rewrite significant parts of the high-level API to understand a large surface area of the low-level API in order to do so. This tends to mean that only a small dedicated community of specialists can really customize the software. These issues are common across nearly all software development, and many software engineers have worked hard to find ways to deal with this complexity and develop layered architectures. The issue in the deep learning community, however, is that these practices have not seemed to be widely understood or adopted. There are, however, exceptions. Most relevant to this paper is PyTorch library, layer design. Much of the innovation fastai is in its new mid-level API. Data callbacks, optimizer, model layers, and metrics. These APIs are what the four fastai applications are built with and are successfully recommended available to the users and can build their own applications or customize existing ones. All right. I'm gonna skip these parts. Low-level API. So they have low-level API has pipelines or transforms, partially reversible composed functions mapped and dispatched over elements of tuples. type dispatch based on needs of data processing pipelines, teaching semantics to tensor objects and ensuring that these semantics are maintained throughout the pipeline, GPU optimized computer vision operations, convenience functionality such as detect decorator to make patching existing object easier, and general collection class with NumPy like API. Alright, so that will be all. Thank you very much for listening. Never ever subscribe and never like these videos. Yeah. Okay, and I hope you like it, and maybe see you next time. Cheers.